Hi ladies and gentlemen, this is Miss Jermaine. So just coming at you with a video for the second half of the day's activity. So in class today, I just sort of want to take a second to sum up what we did in class today. So today we sort of looked at some more isolating for different variables. And then our I cans for today, where I can write and rewrite equations to solve for a particular variable using real-world problems. So we're doing a little bit more of what we've been doing, but now we're really going to be looking at, and we're going to be given a real-world situation. We're going to have to create some equations, and then we're going to have to isolate for different variables, which is exactly what we did in class today. So we talked about those people that were paving the streets. They had a budget. It costs a certain amount to repave roads. It costs a certain amount for a salary, and we had to create an equation and isolate for different variables. We had to solve for P, we had to solve for M, then we had to talk about which equation should we use in different situations, which equation will make it easier to find that solution that they're asking you, given the information that they're giving you. And that's really what we did for the first half. So our activity for the second half, we're sort of expanding on that again, is we're going to be looking at, this is probably my favorite. We're going to be looking at some standard form equations, and with those standard form equations, we are going to be graphing them. And this is sort of a new concept that we've never really done before. So we're going to really deep dive, and we're going to go really slow with it in this video. I probably talked about it a little bit in class today, but I want to really make sure that I cover everything in case I didn't get through everything in class. Okay, so as we know, standard form equations are when we have our x and our y variable, or they could be different letters. We have both variables on one side, and they're equal to a constant. So in this case, we're talking about going to a fair, I believe, no, an amusement park, and x represents the number of rides that he went on, and y represented the amount of money. Oh, no. So y represented the number of rides, x represented the number of games that he had, and the dollar amount a student is spending on the games and rides at different amusement parks. So basically, this is what it's saying. We're talking about, like, for example, in this case, we're talking about the number of games that he played, the number of rides that he rode, and he had a total of $20 that he could spend. If we look at this equation, each one of these has a, well, it's not really a slope, but like a variable of nothing, so that when we can imply that that is a number 1. So each one of these is a dollar if we're talking about money, which we are. So each, a ride is $1, a game is $1. Well, actually, a game and a ride are $1. And he has a $20 that he can spend. Then at the second amusement park, the games cost $2.50 each, and the rides cost $1 each. And he has only $15 to spend. In equation number 3, the games cost $1 and the rides cost $4, and he has a total of $28 that he can spend in a mixture of those two sort of scenarios. So let's take a look at how we're actually going to graph these guys and sort of create some equation lines for these guys. So if we slip and slide down to slide number 10 here, I put a table on here for you to sort of get all of your ducks in a row, right? So let's try to figure out some data points that we could graph on here. And these questions are sort of going to help us to pick some good points here. So if we look at this first question here, it says, what's the number of rides a student could get on if they didn't play any games? So the games is going to be equal to 0 based on that scenario. So he didn't play any games, and he is going to play the rest of his amount of money for the rides. So if he spent $0 on games and he has a total of $20 that he can spend, that means that we have to, one second. That means that we have to plug 0 in for x in our equation and solve for what our y would be. So that would be 0 plus y is equal to 20. So when the games is equal to 0, we would then subtract 0 from each side, which we know is going to get me still 20. We're going to be left with y is equal to 20. When the games is equal to 0, the rides is going to be equal to 20. So if I want to plot that point on my line and I want to graph it, that means I can take one of these points off my pile, and I know that my games is going to be 0. So that means I need to go over on my games axis to 0, and then my rides is going to be up to 20. So I'm going to go up to 20, and I'm going to place a point here. Okay? There we go. That's one of them. So the answer to this question is how many games or how many rides can he go on if he plays no games? In this scenario at this amusement park, he can go on 20 rides. Okay? So then the second question asks us, what's the number of games the student can play if they don't get any rides? So now we're saying the rides is going to be equal to, they're not going on any, so it's going to be equal to 0. And if we take this equation here and plug in 0 for y this time for the rides, and we solve it, we would once again subtract, oh, let me click this box, sorry guys. We would once again subtract 0 from each side, and we would be left with x is equal to 20. Okay, so when the rides is equal to 0, the games is also going to be equal to 20. So if I want to plot that point on my graph, I'm going to go over to 20, up to 0, over to 20, up to 0. And if you look at this, first of all, what do we notice? So we know what this is called. This is called our y-intercept. So now let's use that idea of a y-intercept, and let's think about a name that we might give to this point right here. Well, it's where it hits our x-axis, right? So that means we can sort of say to ourselves, we can give it the name of an x-intercept. So now what I want to do, if you look at this directions down here, it says plot these values on the plane and attach them with a line. So we're going to hit our line button up top here. And I'm going to put my mouse over that first point there, connect it down to that second point there, trying your best. It's not going to be 100% perfect. I like to sort of change the color just so that I can see it a little bit better. I usually turn it to pink, and then I make it maybe 2, just so it's a little bit thicker. So what's the number of games that the student can play if they didn't take any rides? It's going to be 20 games. Okay, so my suggestion to you is when you're going through here and we're trying to create these graphs here, you look at these questions. They're really going to guide you to help you create some of these questions here. So you're going to be plugging in 0 for one of your variables and then isolating and solving for that other variable. So when we look down at 11, let's take a look at what this is asking us to do. So 11 is saying to us, so now we're talking. We're saying if the student played no games, they can get on blank rides. We want to refer back. If they played no games, they could get on 20 rides. So in this box, you're going to write this number 20. So if they go on if they did no games, they can get on 20 rides. For every additional game that the student plays, X, the possible number of rides, Y, does it increase or decrease by what number? So now we're going to have to sort of do a little bit of digging here. We're going to have to calculate some more points here. So if I go and I do one game and I plug 1 into my equation now, I come back up here, I say X, so 1 plus Y is equal to 20. I isolate for my Y by subtracting 1 from each side. And I'm left with Y is equal to 20 minus 1 is 19. So every game that I take, the number of rides is doing what? What's happening to the number of rides? Well, we went from 0 to 1. We went from 20 to 19. It is, in fact, decreasing. And by how many? So every game that I add here, how much is it taking away? It's taking away it is taking away one game from, or one ride from that pile. So it's decreasing by 1. So what is the slope of our graph? Now, if I were to sort of take a slope triangle here, if I were to draw in a slope triangle for myself, I would have a rise of -2 and a run of +2. So -2 over +2 is -2 over +2 can be rewritten as a -1. So the slope of this graph is a -1. I'm going to make this a little bit bigger for us because it's kind of weird that it's so small. What does the graph intercept? Where does the graph intercept our vertical axis? So now you need to, for this question, you need to look back here and you need to look at that vertical axis, that y-axis. Where does it hit that vertical axis? It hits it at a coordinate of over, comma, up, blank, comma, blank. What's it going to be? 0, comma, 20. And let me just put those parentheses around it. Okay? So now we're going to rearrange the equation to solve for y. So I need to isolate for my y now. I need to solve for y, which means isolate for y. So I need to move that x over to the right side. And the way that I do that is by subtracting x from each side. Oh, let me click in this back. Sorry, guys. Minus x from each side minus x from the right side. This can be rewritten as y is equal to 20 minus x, which, if we want to compare to make sure that our slope was correct, oh my goodness, this is a negative x, which, remember, this can be written as a -1x. So that slope of -1 that we found up here is in fact correct. When we isolate, now we're in our y-intercept form, our slope-intercept form, we are able to easily find that intercept value, which we found here, and we were able to easily find that slope value. So we rearranged it for y, and we said that y is equal to 20 minus 1x. You could also say negative x plus 20. That is the same equation. Now, we're saying, what connections do you notice between the new equation and the graph? We look at, and it's the same exact line. We put our y-intercept, we go our slope down 1 over 1, down 1 over 1, down 2 over 2, and it's the same graph. Okay, so it's the same graph. When you look at that y-intercept form, it's going to be this. It's going to represent the same sort of situation. So now your job. Let me tell you what your job is for this afternoon. Okay, so now what you're doing for equation number 2 and equation number 3 is, so your equation number 2 is here. You're going to do the same thing. You're going to find some data points here, answering these two questions, plotting the points, connecting them to create a line. You're going to come down to the next slide underneath. So 12 and 13 go together. You're going to answer these same questions here based on this graph here. Make sure that you remember that this x has a rate of change of 2.5 instead of that 1 that we were using before. Then, once you finish answering these questions for this one, you're going to come down to 14 and 15, and you're going to do the same thing again, except this equation here has a 4y is equal to 28, or x plus 4y is equal to 28. So your job for the next 10 minutes, wait, let me turn my clock on. We're taking 10 minutes right now to let me just reset this. We're taking 10 minutes right now to work through these 4 slides, these 2 separate equations. Here we go. We're starting. Boop. Awesome job, ladies and gentlemen. We're taking another 8 minutes and 28 seconds to work on these slides 12, 13, 14, and 15. Wonderful. We're at another 6 more minutes, 6 working minutes, my friends. Awesome job. We're halfway there. Okay, we're at 4 minutes. Okay, we're at 3 more working minutes. Okay, you have 2 more working minutes, my friends. Okay, I have 1 more working minute, my friends. Let's start to finish up. Thirty more seconds, my friends. 30 more seconds. Okay, we're looking at about 10 more seconds, my friends. Three, two, one. Okay, so what I need for you is I need you guys to flip back to the Zoom screen, and actually the video screen. So I want you to half and half it. So have your video on one half, have your slides on another half. Make sure that you're opening your slides in a separate sort of tab for yourself and pulling down the speaker notes at the bottom so that it is as big as possible. Right? So now let's take a look at some of those answers that we got here. Okay? So if we go down to slide number 12, we had this equation 250x plus y is equal to 15. So I plugged in a 0 for x, and then I plugged in a 0 for y, and I calculated what my values would be. When my x is 0, my y is going to be 15. When my y is 0, my x is going to be 6. Because when I have to divide that 15 by 2.5 to isolate and get that x by itself. So I then plotted those points on my graph here, 0, 15, 6, 0. And I connected them with a line. I did a few more points that would fall on this equation line just so that I could do some work with it later. So I found that when the number of rides, what's the number of rides? When the games is 0, it was 15 games. What is the number of games when the rides is 0? We said for that one, it would be 6 rides. So 6 rides. Games, sorry. Okay, and 15 rides. Now let's take a look at these answers that we got for 13, okay? So if a student played no games, they could get on 15 rides. For every additional game that the student played, x, the possible number of rides decreased, but this time it didn't decrease by 1, it decreased by 2.5, because that was the rate of change on our x value here, right? And our y was 1, so we had a rate of change of 2.5. Okay, so then from there, our slope then, if we wanted to calculate it, we could draw in a slope triangle for ourselves. Every 4 we go down, we go over 2. No, Mr. Main, not exactly. For every 15 we go down, we go over 6. 15 divided by 6 gets me 2.5. So it's a negative 2.5 for our slope because it is going down. As we read it left to right, it is going down. The graph, or the graph's vertical intercept, is where does it hit your y-axis? Your vertical axis is 0, 15. When we rewrite it and isolate for y, we have to subtract 2.5x from each side to isolate or get that y by itself. So we would have y is equal to negative 2.5x plus 15. If you did 15 minus 2.5x, that means the same thing. If we look at this equation line here and we compare it to our graph here, they are the same equation, same slope, same y-intercepts. Okay, then if we look at number 14, slide number 14, we had a little bit of a different equation here where we had the 4 attached to our y. So I plugged in my values here, my x being 0, my y being 0, and I solved my equation. When my x was 0, my y was equal to 7 because 7 times 4 is 28. 28 was equal to my games when my y was 0 because the slope for the rate of change for my x is a 1. So 1 x is equal to 28 when you plug in 0 there. Okay, so how many rides will it be when there are 0 games? It would be 7 rides. How many games will it be when the rides are 0? It'll be 28 games. Okay. So then, if we look at this next piece, this is the next slide is where it gets a little bit trickier, okay? So, if I look at this guy here, let me just pull this guy up a little bit so that I can see it a little bit better, okay? So, if the student played no games, they could get on blank rides. So, if we played no games, we could get on 7 rides. Okay, so when we play 0 games, we're going to get on 7 rides. For every additional game, it decreases by a value of 1/4. And the way that we calculate that is, let me show you. So we think about this guy here, and we could calculate it one of 2 ways. We can do that by calculating our slope here, by looking at our rise and our run. Our rise is 7, our run is 28. 7 divided by 28 is 1/4. So that would be, it would be decreasing by that slope, which is 1/4. The slope of this graph, once again, we calculated by doing our rise over our run, change in y over change in x, 7 divided by 28, and we get, 7 divided by 28 gets me a slope of negative 1/4, a y-intercept of 0, 7, and here's the thing that I want to go through. I want to show you how we're going to rearrange this and solve it and isolate it for y, because this one is a little bit different. So when we look at this guy here, we need to, Mr. Main, 28. We need to move that first. We need to move that x over to the other side. So I'm isolating my y. I need to move that x by subtracting x from each side. Okay? That is pretty much what we've been doing moving forward from where we started, right? So we would be left with 4y is equal to 28 minus x, right? And I'm going to write it as a 1x because we're going to have to do some sort of division here. So now, if I want to isolate this 4 here, I can do that by dividing by 4 because this is attached through multiplication. So to isolate that y, I'm going to have to divide by 4 on each of our terms. So we're going to divide by 4, and we're going to divide by 4. Oh, Mr. Main, divide by 4. So I'm going to underline these sections to show that we are dividing, and we will go from there in a moment. So when we divide by 4 on that left side, we're going to be left with just the y. Y is equal to 28 divided by 4 is 7 minus 1/4. 1 divided by 4, right? 1 divided by 4x, 1/4 x. That is how you go about and isolate for your y there. So you have to divide each of the terms by the 4. And I know that previously we've sort of kept this as one big chunk here, but because the 4 goes into each one of these equally, this 28 namely, we're going to be able to sort of break it into 2 separate terms here, okay? And if we look at this equation here and we look at how it's graphed, it's the same equation, same slope, same y-intercept. So what I want you to do for the last 2 minutes of this time that we have together is I want you to look at these last few questions here, and I want you to go through and I want you to answer these questions as best as you can. I'm not going to go through the answers because I think that you guys can sort of go through those independently. I'm going to leave you today with one moment. I'm going to leave you today with a code phrase for today. Send me an email with watermelon. This is my watermelon hat. So send me a watermelon. Let me know. Actually, let me know. Do you like watermelon? Is it good? Is it not good? What do you think? Let me know. I'll talk to you later. I'll see you tomorrow. Awesome job, guys. Enjoy the snow!